And welcome again. We are going to solve one more problem. So let me read you the statement of the problem solved. Problem. And this is many small holes are drilled in the wall of a measuring cylinder with a vertical axis. Yes, you can see all of these things. The cylinder is filled with water to a height h, and because of which thin jets of water shoot out from the holes perpendicular to the wall. Yeah, of course. What is the shape of the surface of the water jets? And that means we are looking for the envelope of water jets. And there are a few instructions that you must assume that the jets of water do not obstruct each other, and we ensure that a constant water level in the cylinder by continuously refilling it. Yeah, that's fine. Otherwise, we could not have solved this problem. So I think envelope of the outgoing water jets is a symmetric surface rotating about this cylinder. यानी कि we could have told you that envelope of the outgoing water jet is symmetric surface with respect to the axis of the cylinder. Yeah, that's right. So let us consider the plane section. Let us consider a plane section of this surface aligned with the axis of cylinder, and use the coordinate system we provided here, xy axis, in this manner. And let us find a relationship between the coordinates xy of an arbitrary point. And what should be the arbitrary point? This arbitrary point is P, I guess. And it started from a height h minus h, you can see here. So its height is h minus h. And we will simply examine the motion of water jet up to point P and try to find out an equation. And to do so, we know the Torricelli's theorem, the efflux, we can check here. And we all know, as per Torricelli's theorem, or velocity of efflux, this velocity v is going to be under root 2gh. And so to reach the point P, whose coordinate is xy, point P whose coordinate is xy, you can write here x is equal to under root 2gh multiplied by time, so that we get t equals x by under root 2gh. And during this time, the water drop falls a distance half gt square downward, vertically downward direction. So at point P, y can be simply written as from the point of view of this coordinate, it can be h minus half gt square. Yeah, h minus h is this length, and it has been lowered by half gt square, so you can write y will be equal to h minus half gt square, so that we can write here h minus half gt square t square, that is x square by under root 2gh. Yeah, and so we can manipulate this equation for x square, and we can write here simply as x square will become 4h multiplied by h minus y. You simplify the above equation and you will get it. And now I can or from here also I could have written a different equation, like I can manipulate it in a different manner, like this. I can write it as h minus y, that will be equal to h plus x square by g gets cancelled out, x square by 4h. I can write this equation in this manner. H minus y equals x square by 4h plus h. And now I'm going to use something I learned in my class 11 studies, and I'm going to use the inequality for APA, arithmetic mean and geometric means. And I'm going to take this term as A and this term as B, and I know that a plus b by 2 is greater than equal to under root ab, and so that I can write this thing as x square by 4h plus h, that must be greater than 2 under root ab, that is x square by 4h multiplied by h. And this thing, this right hand side will simply come out as x, and I can get something like here that this thing x square by 4h plus h is h minus y. So I can write here h minus y is greater than equal to x. And if h minus y is equal to x, in that case h minus y is this length. You can see here. Let me let me remove all such things so that this point P is here, and we got h minus y. H minus y is the height. If I'm considering any point, I consider this thing. So h minus y equals x. So if I can take this point here and write its coordinate as xy, then this length x, and this length is this, not this length, I'm sorry, this length is h minus y. If I call this y and call this x, then this length is h minus y and this length is x. So we got a shape, and that is the shape of a cone. It's a cone, basically a cone, and here is the angle 45 degree, this angle. I got a cone with half angle 45 degree, and this is the envelope we are looking for, and that is the solution of the problem, and the problem is solved. Thank you very much for watching.